Okay, so now let's look at angle side. Theorem 4.2, the angle side theorem, states that if two angles in the non-included side of one triangle are congruent to two angles in the corresponding non-included side of another triangle, then the two triangles are congruent. So, if angle A is congruent to angle D, angle B is congruent to angle E, and segment AAC is congruent to segment DF, then triangle ABC is congruent to triangle DEF. So let's do a quick proof of theorem 4.2. So we have the same triangles here. We have triangle ABC and triangle DEF. So the first thing that we're going to do here is we're going to state some given information. We're going to pull two parts of our given information out right here, and we're just going to go ahead and say that angle A is congruent to angle D, and that angle B is congruent to angle E, because it's given. And now, because of the third angles theorem, we can say that angle C is congruent to angle F. Now let's pull out that last piece of given information, that segment AC is congruent to segment DF. So now, since we know that angle C is congruent to angle F, and then angle A is congruent to angle D, and segment AC is congruent to segment DF, we can say that triangle ABC is congruent to triangle DEF by angle side angle. So by using the angle side angle postulate, we have just proven theorem 4.2, the angle side theorem. So now let's write a proof using angle side. In the following diagram, we're given that angle M is congruent to angle K, and that segment WM is parallel to segment RK. And we need to prove that triangle WMR is congruent to triangle RKW. So our first step is going to be what? You guessed it, a piece of our given information. So we're going to pull out that angle M is congruent to angle K because it is given. So here's angle M and here's angle K again. We're also going to pull out the other piece of given information, and that's that segment WM is parallel to segment RK. Next we're going to say that angle MWR is congruent to angle KRW because of the alternate interior angles theorem. And next we know that segment WR is congruent to itself, segment WR, because of the reflexive property of congruence. And finally we can say that triangle WMR is congruent to triangle RKW because of angle side. Okay, problem number 4 wants to know if triangle BIF is congruent to triangle UTO, and why or why not. So let's take a look. The diagram shows that two pairs of angles and one pair of sides are congruent. So we have angle B is congruent to angle U, and angle I is congruent to angle T. Segment FB is congruent to segment TO as well. And using the third angles theorem, we can also say that the third pair of angles are also congruent. In order to prove these triangles are congruent, we need to satisfy angle side angle or angle side, which both fail because segment FB and segment TO are not included between the same pair of congruent corresponding angles, so they are not corresponding sides. The triangles are not necessarily congruent, so the correct answer is B. No, segment FB and segment OT are not corresponding sides.